In our interconnected world, where reliance on technology is ubiquitous, the possibility of a solar superstorm wreaking havoc on our digital infrastructure is a cause for concern. Solar superstorms, massive eruptions of energy from the sun, have the potential to disrupt and even permanently damage satellite systems, power grids, and communication networks, including the internet. While such an event may seem like science fiction, scientists and experts in the field of space weather warn that the threat is real and could have catastrophic consequences. Solar superstorms, also known as coronal mass ejection CMEs, occur when the sun releases a massive amount of charged particles into space. These charged particles, if directed towards Earth, can interact with our planet's magnetic field and cause geomagnetic storms. While most solar storms are relatively harmless, a superstorm of unprecedented magnitude could pose a significant threat to our technology-dependent society. The most famous solar storm in history, known as the Carrington event, occurred in 1859. During this event, a powerful CME hit Earth, causing telegraph systems to fail and even sparking fires in some cases. The technology of that era was far less advanced than today, and the impact was limited. The internet, which forms the backbone of our global communication and information exchange, is vulnerable to the effects of a solar superstorm. The interconnected network relies heavily on satellite communication, which could be disrupted by intense bursts of solar radiation. Additionally, power grids and data centers that support the internet infrastructure are susceptible to geomagnetic disturbances caused by solar storms. Experts predict that a sufficiently powerful solar superstorm could damage or destroy satellites, disrupt power grids, and induce widespread electronic failures. The result could be a prolonged and widespread loss of internet connectivity with severe economic, social, and geopolitical implications. While the threat of a solar superstorm disrupting the internet is a serious concern, efforts are underway to mitigate the risks. Space agencies and researchers are developing advanced space weather monitoring systems to provide early warnings and allow for proactive measures. Additionally, engineers are designing more resilient satellite and power grid systems to withstand the impacts of intense solar activity. Governments and organizations are also investing in contingency plans to ensure that critical infrastructure can be quickly restored in the event of a solar superstorm. These measures include the development of emergency communication protocols, backup power systems, and strategies to minimize the impact on essential services. As our reliance on technology continues to grow, the potential for natural disasters, such as solar superstorms, to disrupt our interconnected world becomes more significant. While the likelihood of a catastrophic event is still uncertain, the scientific community and policymakers must take the threat seriously and work towards implementing preventative measures. The development of robust monitoring systems, resilient infrastructure, and effective contingency plans are crucial in safeguarding our digital way of life from the potential consequences of a solar superstorm. Preventing a solar superstorm entirely is beyond our current technological capabilities, as these events are natural occurrences driven by the sun's complex and dynamic behavior. However, while we cannot prevent solar superstorms, we can take measures to mitigate their impact on Earth's technology and infrastructure. Here are some strategies that scientists and engineers are exploring to reduce the risks associated with solar superstorms. Developing advanced space weather monitoring systems is crucial. Early detection of solar activity allows for timely warnings, giving governments, industries, and individuals the opportunity to take precautionary measures. These warnings could include temporarily shutting down or putting satellites into safe mode, preparing power grids for potential disruptions, and alerting astronauts in space. Designing and implementing more resilient technology and infrastructure can minimize the impact of solar superstorms. This includes developing spacecraft and satellites that can withstand the intense radiation and magnetic fluctuations associated with solar storms. Similarly, constructing power grids and communication networks with built-in safeguards can help reduce vulnerability. Governments and organizations should establish comprehensive contingency plans to address the potential consequences of a solar superstorm. These plans may involve creating emergency communication protocols, developing backup power systems, and having strategies in place to quickly restore critical infrastructure. Space weather is a global phenomenon, and collaboration between countries is essential to address the potential impacts of solar superstorms. Sharing data, expertise, and resources on an international scale can enhance our collective ability to predict, prepare for, and respond to solar activity. Continued research into the nature of solar superstorms is essential for improving our understanding of these events. Advances in space weather forecasting, as well as the development of new technologies, can contribute to more effective prevention and mitigation strategies. While we cannot prevent solar superstorms, a combination of early warning systems, resilient infrastructure, contingency planning, international collaboration, and ongoing research can significantly reduce the risks associated with these natural events. As technology continues to advance, scientists and engineers will likely develop even more sophisticated methods to protect our increasingly interconnected world from the potential impacts of solar superstorms.